Hello students. In this video, I'll explain about physical properties of alkyl and aryl halides. See, generally physical properties are not important, but only those physical properties in which some reason is involved, they are important physical properties. So we take up the first physical property, that is physical state. See, low molecular weight alkyl halides, they are colorless gases, and higher molecular weight alkyl halides, they have pleasant smell and they are generally liquids. And bromo and iodoalkanes, although they are colorless, but in the presence of sunlight, they become colored. Bromoalkanes develop brown color and iodoalkanes develop violet color in the presence of sunlight. This is due to their photochemical decomposition in the presence of sunlight. Bromoalkane on decomposition will produce bromine, which is brown in color. Iodoalkane on photochemical decomposition will produce iodine, which is violet in color. Otherwise, they are colorless. Aryl halides are colorless liquids or solids. Now coming to second physical property, that is boiling points. Boiling points of alkyl halides are higher than the boiling points of corresponding alkane from which they are derived. And there are two reasons for this. Number one, molecular weight of any alkyl halide will be higher than the molecular weight of corresponding alkane. Second reason is alkyl halides are polar in nature because halogen is more electronegative than carbon. And due to this polar nature, negative end of one alkyl halide molecule will attract positive end of another alkyl halide molecule. This is called dipole-dipole attraction. So one reason for higher boiling point of alkyl halides is they have higher molecular weight. Second reason is polar nature, due to which they have dipole-dipole attractions. Molecular weight increases with increase in number of halogen atoms. So boiling point will also increase with increase in number of halogen atoms in the molecule. Like if we consider chloromethane, dichloromethane, trichloromethane, as the number of halogen atoms increases, molecular weight increases, and therefore boiling point also increases. If we consider different alkyl halides which have the same alkyl chain, but different halogen atoms. If we consider fluoroalkane, chloroalkane, bromoalkane, iodoalkane, all of them, let us say, have two carbon atoms, fluoroethane, chloroethane, bromoethane, iodoethane. If alkyl chain is same and halogen is different, then their boiling points increase in this order. Why boiling point increases in this order? The reason is increase in molecular weight in this order, because atomic weight of the halogen will increase in this order. Second reason is size of halogen atom. You know, as we move down the group in the periodic table, atomic size increases. That is why size of halogen also increases in this order. As size of halogen increases, it means surface area of molecule increases. When surface area increases, naturally van der Waals force of attraction between particles will also become stronger, and this is the reason boiling point increases in this order. Now, if we compare boiling points of different isomeric alkyl halides, then boiling point decreases with increase in branching. When branching increases, surface area of the molecule decreases because molecule becomes more and more spherical with increase in branching. And sphere, you know, has the minimum surface area. So more the branching, lesser is the surface area, weaker will be the van der Waals forces of attraction, and therefore lower will be the boiling point. So this is the reason boiling point of isomeric alkyl halides decreases with increase in branching. Coming to next physical property, density. Fluoroalkanes and chloroalkanes, they are lighter than water, that is density less than 1 gram per cc, while bromoalkanes and iodoalkanes, they are heavier than water. Now, if we consider same alkyl chain but different halogen atoms, their density will increase in this order. Why density increases in this order? This is due to increase in molecular weight. Density also increases with increase in number of carbon atoms. Means if we take same halogen but different number of carbon atoms in the molecule, then density will increase with increase in number of carbon atoms. For example, chloroalkanes, chloromethane, chloroethane, chloropropane, as the number of carbon atoms increases, molecular weight increases, and therefore density also increases. So density increases with increase in atomic weight of halogen. Number two, density increases with increase in alkyl chain. It means which alkyl halide has the minimum density. Alkyl halide which has fluorine as halogen, and that too only one fluorine atom. Number two, with smallest alkyl chain, will have the least density. So least density will be CH3F. Chloroethane has the least density because it contains halogen with the lowest atomic weight. Number two, it has the shortest alkyl chain. Coming to next physical property, that is solubility. See, generally we say that like dissolves like, means polar compounds are soluble in polar solvents, non-polar compounds are soluble in non-polar solvents. That is the general rules. But alkyl halides are polar in nature. Water is also a polar solvent, but alkyl halides as well as aryl halides, they are not soluble in water, or we can say they are slightly soluble in water, whereas they should be soluble. Why it is so? This is because when we dissolve an alkyl halide in water, let us say these are many molecules of alkyl halide, they have dipole-dipole forces. These are many molecules of water, they have hydrogen bonding between them. So when we dissolve alkyl halide in water, dipole-dipole forces between alkyl halide molecules will break, for which energy is required. Similarly, hydrogen bonding between water molecules will break, for which energy is required. It means during formation of solution of alkyl halide in water, total energy required will be energy required to break dipole-dipole forces plus energy required to break hydrogen bonding. This is the total energy required. After dissolution, new attractions will be formed between alkyl halide and water. And these attractive forces formed between alkyl halide and water are weak. Therefore, energy released during formation of these new attractive forces, these attractive forces release small amount of energy. So overall, we can say total energy required to break dipole-dipole forces and hydrogen bonding in water is more, whereas total energy released during formation of new attractions between alkyl halide and water, they are weak. Less energy is released. This is the reason halides are insoluble in water, but they are soluble in organic solvents because energy release and energy required are comparable, means almost same. Next property, melting point. See, as far as boiling points are concerned, boiling points of isomeric dihalobenzenes. If we talk about isomeric dihalobenzenes, we are talking about orthodihalo, paradihalo, and metadihalobenzene. So their boiling points are close to each other. Boiling points are not much different. But Volume, but melting points of these isomeric dihalobenzenes are widely different. They have large difference. It is found that melting point of para-dihalobenzene, para is 1,4, is approximately 70 to 100 degrees centigrade higher than the melting point of ortho and meta isomer. I'll repeat, melting point of para-dihalobenzene is 70 to 100 degrees centigrade higher than the melting point of ortho and meta isomer. This is because molecules of para isomer, they are symmetrical, and due to symmetrical structure, they pack closely in the crystal, and due to close packing, attraction between molecules are strong. Therefore, more energy is required to separate them. Last physical property, inflammability. Inflammability means how easily do they catch fire. See, any compound which contains halogen is less inflammable than the corresponding hydrocarbon. And more the number of halogen atoms, higher the percentage of halogen in the given compound, lower will be the inflammability of that compound. At airports, that conveyor belt is made up of a polymer which contains halogen. It is neoprene. Due to the presence of large halogen atoms, that belt, the polymer of that belt is non-inflammable. Same polymer is used in making conveyor belts in coal mines and other places. You know, CCl4, carbon tetrachloride, contains very high percentage of chlorine, and this is the reason this is non-inflammable. Moreover, it is used to extinguish fire. CCl4 is non-inflammable and also used to extinguish fire. This is commercially known as Yes, so I was telling that carbon tetrachloride has very high percentage of chlorine present in it, and this is used to extinguish fire. Commercially, this is sold under the name pyrene. Pyrene is the commercial name, and it's used for extinguishing fire. So that's all about physical properties of alkyl and aryl halides.